NASA might be shut down, but it's still making headlines. NASA scientists announced that a space probe called Voyager 1 was the first man-made object to reach interstellar space. But who were those scientists? Two of them, it turns out, worked just minutes from West. John Gurnett is a physics professor at the University of Iowa. Bill Kurth is a research scientist working at his lab. I stopped by their offices in Van Allen Hall to ask a few questions about the Voyager mission and about something we're a little more familiar with, science education. Could you describe the Voyager 1 mission and what your role in it has been?
Okay, so Voyager, actually there's two spacecraft, and they're both still sending data back on a daily basis.
They flew by the outer planets, Jupiter, Saturn, Uranus, and Neptune.
The goal was to get into interstellar space.
And it turns out we can use gravity assist at Jupiter and Saturn,
which took advantage of the planetary alignments of Jupiter, Saturn, Uranus, and Neptune.
And when the spacecraft flies by Jupiter, the gravity of Jupiter pulls on it, kind of slings the spacecraft away at a higher velocity.
So instead of taking 30 years, for example, to get to Neptune.
And this allowed us to get to Neptune in 12 years.
The mission was redefined as an interstellar mission to study the outer reaches of the sun's atmosphere. We call it the heliosphere.
How has your education or your childhood or young adulthood influenced where you are today?
Oh, there have been a lot of influences, I guess, in my life. I basically got interested in electronics in high school.
Let's see, I was kind of an amateur astronomer when I was in junior high and high school.
I used to build and fly model airplanes, radio-controlled model airplanes.
I had a little telescope, and I kind of dabbled in that.
And I arrived here at the University of Iowa in 57. And I don't know if you remember what happened in 1957. Sputnik 1 was launched. It had a tremendous impact on the United States because we had a Russian object flying over us, and that was in the middle of the Cold War. And so the U.S. tried to catch up, and they finally launched a spacecraft in 1958, and it had James Van Allen's Geiger tube on it. And it was such an interesting thing, the instrumentation, rockets, and space flight, that I went over to his office and asked for a job.
I came down here and was talking to one of my TAs for a lab that I took as a freshman, and discovered that he was studying electric fields in the auroras using one of the University of Iowa satellites. And I wasn't really looking for a job, but he said, do you know Fortran? Can you debug code for me? And so I started working for him, and I was kind of hooked.
So what advice would you give to current students who are contemplating perhaps a career in science?
I would say the most important advice I could give you if you're interested in going into science, at least anything like physics or engineering, is learn mathematics.
Certainly take math.
Know mathematics very well, because it's the key to understanding, frankly, the universe.
You never have too much math.
Even biology, you've got to know some things about how do things work, and that's usually a mathematical description.
But you know, I think being broad and well-rounded and reading on a lot of subjects, and I think is also important. I think it helps you put what you're doing in science in context to what else is going on in the world.
So how do you think STEM education has changed since you were in school?
Well, I think it's much better than it was when I was in school. I don't think that my physics class, for example, was nearly as good as my son's class at West High was.
Now, there are new electronic things in classrooms, but I'm not terrifically impressed with those, frankly. But I think you want to stick with teaching basics, and I don't see that that's changed all that much.
I went to a lecture here by a person who studies science education, and their point of view was that the science curriculum in high school is taught all backwards, that starts with biology and then goes to chemistry and then ends up in physics, and they thought maybe it would be better if you start with physics and go the other direction, because everything's based on physics, and once you know physics, then chemistry comes from that, and then once you got chemistry and physics, then you can start worrying about life sciences and biology. I think that would be an interesting experiment to do.
I have one final question. What is perhaps the most memorable or one of the most memorable moments that you've experienced while you've been working on the Voyager missions?
The final discovery that we're in interstellar space. That is the most memorable moment, when we first looked at the plot that made us realize that the spacecraft has finally reached the interstellar plasma, or as we often refer, interstellar space. And I don't know, it's just a moment of discovery. All scientists that have come up with some kind of discovery have that same feeling. It's just, oh my gosh, it's actually happening.
Want to find out more about the Voyager mission? Visit voyager.jpl.nasa.gov.